Welcome back to the channel, everyone. Today we're trying out a new type of video. Instead of doing practice problems with our 4 types of problem sets, we're going to be doing our first SAT content review, going over everything we've kind of learned from these problems, specific formulas, and key concepts you need to know. So if you do find this video helpful, please leave a comment or with any suggestions of what you would like to see in the future. So we're going to start out with our first section of linear functions. So with that said, we have multiple forms that these linear functions of lines can appear in. And the first, which is going to be our slope-intercept form. And this function is represented by y is equal to mx plus b, where y is our y value, x is our x value, m is the slope, and b is the y-intercept. Second form is point slope form, which is represented by y minus y1, which is equal to m times x minus x1. I don't really suggest really putting all your effort into memorizing this one because you can kind of navigate around it. However, it is useful to know. And then looking at our next one, we have the formula of our standard form of a line, which is ax plus by is equal to c. C is a constant value, b is a constant value, a is a constant value, and it's just the coefficients of each one. And now we have also, last but not least, our formula for slope, which is m is equal to y2 minus y1 over x2 minus x1. We've used this one almost on every day of the channel, which is very significant if you're going into the SAT. Now also, some terms you need to know for linear functions are for sure x-intercepts, y-intercepts, and the first is when y is equal to 0, and the second is when x is equal to 0. So know each of those, know how to find each of them. So if you have your y equals mx plus b formula already with the m and b already figured out, to find the x-intercept, you would plug in 0 for y, and vice versa. If you're trying to find the y-intercept, you'd set x as 0. Okay. Looking at our next section, we're going to move into advanced math formulas, which is really your quadratic equations. And remember, a quadratic usually looks a little something like this. And that would be y equals x squared as an example of a quadratic equation. But ignoring that, we're going to look at some formulas that you must know. And the first is the quadratic equation. And this is known as negative b plus or minus the square root of b squared minus 4ac over 2a. And remember, these values of a, b, and c are found in your quadratic. So if your equation is, for instance, we're going to do an example over here. If your equation is y is equal to 3x squared minus 4x plus 9, your a value is going to be 3, your B value is going to be -4, and your C value is going to be 9. So you need to know how to find each. It's really just the coefficient of each one. Okay. Looking at our next formula, you need to know it's not really a formula, but it's the form that quadratics can appear in, and this is vertex form. And this is seen as y is equal to a times x minus h squared plus k. And you can do this by manipulating, like our example up here, into this. But for clarity, the purpose behind this form of quadratics is to find your vertex. And your vertex can be found with the point h, comma k. So whatever your h value is and whatever your k value is, that's going to be the vertex of your parabola. And once again, we also have standard form for quadratics, and this is going to be represented as y is equal to ax squared plus bx plus c. Okay, another big part of advanced math is factoring. So you're going to have first the square of a sum. So this is just going to be a squared plus 2ab plus b squared. Next, you're going to have the difference of squares, or we'll do the square of a difference first, so it's a little more organized. So this is just going to be a squared minus 2ab plus b squared. You can just FOIL, but it's a little faster to just know this by hand, especially on a time test. And then lastly, we have the difference of squares, which is a squared minus b squared. And this is kind of reverse engineering it. Since you already don't have it in this form, you're going to put it in factored form, which is a plus b, a minus b. Very important to know this. I'm going to put an asterisk here. Okay. Next, we have our radical and exponent rules. So, radicals and exponents. So, we have a lot of rules here. We're going to start with our exponential rules, and we're going to say for the product rule, we're going to give examples for each one. X to the a times x to the b is equal to x times a plus b. And we also have the power of a power rule. And this is simply if you have x to the a to the power of b, this is equal to x to the ab. We also have the zero power rule, which says if you have x to the 0 or any variable to the 0, it's always going to equal 1. This is the same if you had 3 to the 0. It's also going to be equal to 1. Any constant to the 0 is 1. Anything to the 0 is 1. So just know that. Okay. We also have the negative power rule. It's very irrelevant to know the names of these, just know what they are. But the negative power rule means that if you have x to the a, but it's a negative a, so x to the negative a, it's going to be equivalent to 1 over that same power without the negative, x to the a. And similar to the product rule, I'm going to write this over here. You have the quotient rule, which is when you have x to the a over x to the b, this is going to simplify down to x to the a minus b. So you see how these two are similar over here. I'm going to put a asterisk next to this one and next to this one, since they're the most frequently appearing ones I see on these tests.